Today's lesson, we're going to use tables to identify proportional relationships, and the goal by the end of this is we'll be able to use tables to identify whether or not relationships between two quantities are proportional. So, a little vocab to start off with. We say when two quantities are proportional, they have a constant rate or a ratio. That constant rate is called the constant of proportionality. We will be dealing with that term for the next few lessons. So we're going to use or create tables in this lesson to determine if two quantities have a proportional relationship. So for example, move this out of the way, we will determine whether the cost of coffee is proportional to the number of pounds. If the relationship is proportional, then we identify the constant of proportionality. Here's how we do it. Step one, we're going to use the order given in the question to set up a ratio. So in the problem, it asks us whether the cost of coffee is proportional to the number of pounds. So look at the first ratio shown in the table, and we've got $3 for every 1 pound. So there's our ratio. Notice the labels are included. Next, we find the unit rates of the other ratios by simplifying them to see if they're equal to the first. So our other unit rates should all work down to equal 3 over 1. So I'm sure everybody can do this in your head, but we're going to show this now. Let me get this a little more arranged here and move that out of the way. So we see we've got, let me get the table labels, excuse me. We have $6 here for 2 pounds of coffee. So $6, 2 pounds, it works down to $3 over 1 pound. And that works out, same as the original. Next, we have $9 shown for every 3 pounds. So we check $9 for 3 pounds, and it works down to 3 over 1. It checks out. The last one we have is 12 to 4. $12 for 4 pounds. And again, that will work down for us to 3 over 1. So every unit rate checks out. Therefore, this shows a proportional relationship. And then for the constant proportionality, the first number of the unit rate. So in this problem, the constant of proportionality is 3, because in our unit rates, 3 is the first number. Do a few more examples. So we want to know if number of legs is proportional to the number of spiders in this table. So again, write the first ratio in the given order. So we have legs of spiders. We have 8 legs for every 1 spider. Find the unit rates of the other ones. Okay, so 16 legs of 2 spiders. Works us down to 8 over 1. Checks out. 24 legs for 3 spiders. It works down to 8 over 1. Checks out. And then finally 32 legs for 4 spiders. Works down to 8 to 1. It checks out. So we have a proportion. And then the constant of proportionality. That's that first number in the ratio. So the unit rate, it's 8. 8 is our constant of proportionality. We increase by 8 every time. Okay, now we have this problem. Determine whether the distance traveled is proportional to the time traveled. And so, find that constant proportionality. So, first ratio of the given order, we have 50 miles traveled. So 50 for our D. Sorry, we'll say 50 m for miles for every 1 hour. Now let's test the other ones. Okay, we'll go with 70 miles in 2 hours. And it works down. Remember our unit rate, we have to have over 1. That becomes 35 miles for 1 hour. So we can tell right there our work is done. This is not a proportion. Therefore, we have no constant of proportionality. So go ahead and try these two problems you want on your own. Okay, pause the video and answer those two questions, A and B. Otherwise, keep the video running and do it with me. So the first table shows the relationship between cans of water to cans of concrete. There's our initial unit rate, 4 to 1. Now we look at the others, 8 over 2, right? 8 water, 2 concrete, becomes 4 water to 1 concrete, so it checks out. 12 water to 3 concrete, becomes 4 to 1. It checks out. And then 16 water to 4 concrete, again becomes 4 water to 1 concrete. It checks out. So this one is a proportion. Our constant of proportionality is 4. Then number 2, looking at total squares to shaded squares. So our initial ratio, as I try to stretch the microphone out here, is right here at 8 to 1. 8 shaded, 8 total to 1 shaded. So let's test out the second one. We've got 15 total for 2 shaded, which when it works down becomes 7.5 total squares to 1 shaded. That does not work. This is not proportional. There is no constant of proportionality. This concludes your lesson on proportions in tables.